Alright, today we're going to start with radical equations. We are on page 125. We've updated our table of contents. And the title of this first part is Solving Square Root and Other Radical Equations. Solving square root and other radical equations. Bless you. All right, a radical equation is an equation that has a variable Is that zoomed in enough for y'all? Okay. In a radicand, remember radicand is the part of a radical that's under the radical sign. That's the radicand. Or a variable with a rational exponent. Rational is just the unit that we came off of. Remember, rational, fraction, that's what rational is. In this lesson, assume that all radicals and expressions with rational exponents represent real numbers. So we're only going to be talking about the real number system in this lesson, okay? In this lesson, assume all radicals and expressions with rational exponents represent real numbers. Alright, so just because you see an equation that has a radical sign in it, that does not mean it's a radical equation. To be considered a radical equation, you have to have a variable in the radicand. Like in this example, our radicand is 2x minus 3. That's what's under the radical, right? If I just had square root of 2, I could just simplify that without doing anything special. But because that variable's in there, we call it a radical equation, and so you got to do something special. The number to the left of the radical, if we have one that's being multiplied by the radical, is called the coefficient of the radical. Coefficient, just like when we have 5x squared, 5's coefficient, right? Well, a radical has a coefficient too. 3 is being added to the radical, that's not its coefficient. Alright, so technically in this one the coefficient would be 1. But radicand is what's under the radical. In the arm, do y'all remember what that's called? In the little arm of the radical? Index. That's the index. If there's no number in the index, we're taking the square root. But if there's any other number, you're taking whatever root that is. Like if there's a 3 there, we'd be taking the cubed root. That means we want 3 of the same factors. If there was a 4, we'd be taking the 4th root. We would want 4 of the same factors. Square root, we just need 2 of the same factors. So we know like 9's a perfect square. Its square root is 3 because we have 3 2 times. All right? What's the cubed root of 27? Anybody know? 3. Cubed root, we want 3 of the same factor. 3 times 3 times 3 is the cubed root. What's the cubed root of x cubed? X. What's the cubed root of x to the 6th? It's x squared, right? How many groups of 3 do we have? 2. It's x squared, which we'll get into more of that as we go. We could spend a whole 2-day lessons on that, but we'll just kind of embed it within the lessons. All right, so if I want to know what x is under this radical. I got to figure out what it is that when I multiply it by 2 and subtract 3 and then take the square root and add 3, that it's going to give me 8, okay? So the first thing you're doing when you have a radical expression is you're going to isolate the radical on one side of the equation. It doesn't matter which side, but you're going to isolate it. So that means, like right now it's on the left side of the equation. If that 3 weren't there, it would be isolated because you would just have the radical sign and the radicand. But since that 3 is there, we got to get rid of it, okay? And it may already be isolated, but if it's not, you got to isolate. So how do you think we're going to get rid of that 3? Subtract it. If the 3 was the coefficient, if it was 3 radical 2x minus 3, how would we get rid of that? Divide. But this is just being added to it. So we'll subtract 3 from both sides of the equation. 3 minus 3 is 0. We don't need to write that. And then plus, if that was a minus sign, we would need to write a minus because we'd have to divide by -1. But we don't. It's a positive. So square root of 2x minus 3. And I didn't mean to put parentheses there, but it's okay. It didn't hurt anything. And 8 minus 3 is 5. When we have x squared, how do we undo that so that we can find x? What's the inverse of squaring something? Square rooting it, right? Well, now we have something that's being square rooted, and we want to get rid of it. So what do you think the opposite of taking the square root is? Squaring it. So if we're taking the square root of 2x minus 3 and we want that radical sign to go away, we're going to square it, and that will make it go away. So you can't just do that to one side. You have to do it to both sides. So I'm going to rewrite my steps so that in my notes I can tell what changed from one step to the next, like good note takers do. And I'm going to square both sides. What do you think the square root of 2x minus 3 quantity squared is? Just 2x minus 3, right? Because the square root of 2x minus 3 times the square root of 2x minus 3 don't have two of the same factors. 2x minus 3 times 2x minus 3. So the square root would just be 2x minus 3. Equals, what's 5 squared? I'm so glad y'all didn't say 10. 25. Now what? Yeah, because we're just going to solve for x, right? So now it's the easy part. So add 3 to both sides. Two x equals 28. Divide by 2. And x equals 14. Now, unfortunately, you do have to check for extraneous solutions because they're going to come up with these radicals sometimes. You can check in the original problem. Sometimes the original problem is complicated. There's like too much to it. So me personally, I like to go down to the step where I have isolated the radical because the original equation and this part of the equation mean the same thing because I kept balance on both sides. What I did to one side, I did to the other, so I kept balance. So this equation means the same thing as this equation. This is just going to be easier to plug in 14 for x and simplify, right? So that's personally where I would check. You can check from the beginning, but don't check from the point after you take the square root of both sides. Don't check from there. So I'm going to check at the square root of 2x minus 3. Again, I don't know why I drew in those parentheses, but they don't hurt anything. So 2 times x, that's going to be 2 times 14 is 28. 28 minus 3 is 25. And what's the square root of 25? 5. 5 equals 5, true statement. So we know that yes, x equals 14 is our solution. Right on.
If it didn't work out, what would it be?
If it didn't, because that's our only option, it would be no solution. A lot of times, when we get to rational exponents, because we can convert a radical to a number with a rational exponent, and a lot of times if it starts with a rational exponent and it ends, you may get 2 answers, and then that's when you may see extraneous more often. But you should kind of get used to checking your answer either. Also, it could mean that you didn't do the problem right. So it's not 100% that it's extraneous. It's extraneous if you did the problem right, but it doesn't work out. All right, page 126. Now in this example, be careful because the radicand is 4x plus 1. I am subtracting 5 from the radical. Make sure that your problem doesn't look like the minus 5 is part of the radicand, because it's not. So do we have a variable in the radicand? Yes, then this is a radical equation. First thing I have to do is isolate the radical if it's not already. How am I going to do that? I'm going to add 5 to both sides. So I'm left with the square root of 4x plus 1 equals 5. Now what? Square both sides. Now, on my first notes, I rewrote that so that you could see I'm using colors, so Well, let's just go ahead and write another step so it's not confusing. So the square root of 4x plus 1 equals 5. I'm going to square both sides because that is the inverse of taking the square root. It will undo taking the square root. And what's the square root of 4x plus 1 quantity squared? 4x plus 1 equals 25. Now we'll just solve for x. And x equals 6. Anybody have questions on that? All right, let me just check that real quick. Again, I can check it in the original problem. Personally, I like to check it once we've isolated the radical. So 4x plus 1, that'll be 4 times 6 plus 1 equals 5, which 4 times 6 is 24, plus 1 is 25, and the square root of 25 is 5. I know the square root of 25 is positive 5 and negative 5, but we're just taking, usually you only look at the positive square root, except for when you're solving equations with radicals and you do the positive and negative. But like in this case, when we're just checking that, we wouldn't put positive 5, negative 5, because we just want to know, can it equal positive 5? And it can. Pretty easy, right? Right, Miss Rayleigh? Oh no. All right, let's do another one. How about 3 square root x, and then I've got a plus 3 that's not under the radical equals 15. What do you think I'm going to do first? Minus 3. Because of this 3, the coefficient, or because of this plus 3?
Plus 3.
Because of the plus 3. I'll subtract 3 from both sides. And I'll get 3 square root x equals 12. Now what? I divide by 3. Because square root of x is being multiplied by 3. The 3 square root x divided by 3. 3 divided by 3 is 1. So it just leaves me with the square root of x equals 4. Not square root it, but square it. I knew what you meant. What's the square root of x? Quantity squared. X equals 16. Let me check this real quick. And I would check this into once my x is isolated. You can check it in from the beginning. That's just fine. It's just going to be more work. But this equation means the same as this equation because I've kept balance on both sides. So that's super easy. We have the square root of 16 equals 4. True statement? Yes, it is. Anybody have a question on that one? All right, let me show you one more, and then I will give you some to do on your own. How about, it's like magically appeared over there. The cubed root. Cubed root. My index is 3 now. Cubed root of 2x plus 1. And that equals 3. Is my radical isolated, or do I need to do something in order to isolate it? It's isolated. Yay. Okay, so we need to solve, we have a variable in the radicand. That means it's a radical equation. Could I just subtract 1 from both sides? No. You can't do anything with the radicand until you get rid of that radical. So, what do you think the inverse of taking the cubed root is? Cubing it. So if this is the cubed root, to get rid of that, we'll cube it. What if it was the 4th root? We would raise both sides to the power of 4. That doesn't have a neat little saying like cubed root and square root do. But if this was the 4th root, we would raise both sides to the 4th power. If this was the 5th root, we'd raise both sides to the 5th power. And that would get rid of the radical. But since it's a cubed root, we'll cube or raise both sides to the 3rd power. So that's the only difference. So what do you think the cubed root of 2x plus 1 quantity cubed is? 2x plus 1. Looks complicated? It's not. What's 3 cubed? 27. Not 9, right? 3 cubed does not mean 3 times 3. It means 3 times 3 times 3, which is 27. Subtract 1 from both sides. 2x equals 26. Divide by 2, and x equals 13. Let me just check that real quick. This one, my original problem, the radical is already isolated, so that's where I'm going to check from. 2x plus 1, that'll be 2 times 13 plus 1 equals 3. So the cubed root of 2 times 13 is 16. 16 plus something, I did something wrong. 2 times 13 is not 16. 2 times 13 is 26. And 26 plus 1 is 27. And what's the cubed root of 27? 3. Checks out. 13 is my answer. Anybody have any questions on that? Awesome sauce. All right.